With relevance to our second lesson, we're going to continue with functions today, and we're going to focus today on inverse functions, and we're also going to focus on split functions or piecewise functions, which is another type of functions which we're going to be using quite a lot from now. These are very interesting concepts. Some of them are very abstract, so it's going to require quite a bit of understanding, but I hope that this video makes it easy. You can actually go through the video as many times as possible. In order to introduce inverse function, what I'm going to do first is I'm going to revert back to last week when we were studying the concept of function, and what I'm going to do this time is I'm going to focus on what the variation is to get the inverse of a function. Okay, so last week, you remember, we started introducing functions by using your number machines, which basically is perhaps the easiest way to try and understand functions. Remember, when you have a function, basically your function has an input, a rule, and an output. Okay, and then if we have the input and we go through the rule, we'll be able to find the output. Now, when it comes to the inverse of a function, the inverse of a function is the one that achieves the reverse of this. So what basically this means is that when I have the inverse of a function is how can I get from the output back to the input. And remember last week that what we did was, and I'm going to draw another graph here, I'm going to use the same rule, but instead of having the input, I'm going to start from the output, and then I'm going to work backwards from the output. So let's say my output was 8, my another output was, let's say, -1, and another output was 17, just to have a view. Okay, so let's say we want to work our way back to our input. Okay, in this case, what I'm going to do is I'm going to say, so how do I get back to your input? Now, the rule basically said that whatever you put in, you first multiply by 3 and then you will add 5. The inverse rule basically means is you're going to go backwards and you're going to use the opposite of operations or the inverse operations to the ones that you've used in the reverse order as well. So here we first did multiply by 3, then added 5. So to get to the inverse, we are going to first subtract 5 and then divide by 3, and that would give us our input. So if I start from 8 and I say 8 minus 5, which is 3, and 3 divided by 3 is equals to 1, what this is basically telling me is that if I use the input 1, I will be able to get to 8. Okay, now from -1 the same thing. So if I start with -1 and I go -1 minus 5, which is -6, and that divided by 3, which is -2, I've been able to find the input. And if I do 17 minus 5, which is 12, and 12 divided by 3 is 4, so I have been able to calculate the input. So from input to output, okay, what I used was, I used the rule 3x plus 5. Now, from output to input, what I did was, I used the rule, okay, x minus 5 divided by 3. So basically, again, what I did was I just went backwards using the reverse operation. So first thing here is the last thing that I do here, but in the opposite operation, last thing that I do here is the first thing that I do with the opposite operation. So 3 times x plus 5, when you reverse it, that will be first subtract 5, then divided by 3. Opposite of first multiplying by 3 and then adding 5. Okay, and that's how we found the inverse. Now, in terms of notation, if a function is notated as f of x, then the inverse will be notated as f minus 1 of x. And it's very, very important to understand that that minus 1 has nothing to do with the rules of exponents. So f minus 1 is never equals to 1 over f of x. This is a very common mistake. That people, because they see the minus 1, they say, well, according to the rules of exponents, f to the minus 1 will be 1 over f of x. It is not that is not the case, so be very aware of this common mistake. This basically means the inverse of a function. Next, I'm going to show you how do we find the inverse of a function by using algebraic rule. Welcome back. Here we have a function, the same function that we had before, only that this time I'm just going to do a full algebraic solution and finding the inverse of the function. I've got the function 3x plus 5. How do I go about finding the inverse of a function? So there's a set of steps that we follow. The first step is actually to convert this to a form y equals mx plus c, okay, or to y equals something in terms of x. So basically exchange the f of x by y and write the equation in the form y equals 3x plus 5. And that's step number 1. Okay, that is my rule. So what I'm going to do in order to reverse my rule is I'm going to exchange the x and the y. So I'm going to then say this equation, I'm going to rewrite it as x is equals to 3y plus 5. Okay, so I've exchanged the x and the y, and I will show you graphically later how this works. So exchanging the x and the y will now allow me to find the inverse of a function. How? By making y the subject of the formula, and this again is just basic algebra. How do I make y the subject of the formula? I first subtract 5 to the other side, so x minus 5 is equals to 3y, and now to find the value of y, I will then divide both sides by 3, and therefore y is equals to x minus 5 over 3, or you could also say this is x over 3 minus 5 over 3 if you want to split it into individual fractions. You're not necessarily to do that. And then the last step is just remember that we started with this type of notation. We have to then reverse back to the original notation, and remember we will now say that the function that we've got here is not the original function, is the inverse of the original function. What happens now? We write it as f minus 1 of x, which is equals to x over 3 minus 5 over 3, or you could also write it as x minus 5 over 3. And that's in essence what you need to know about inverse functions. I'll talk about domain and range of inverse function. If I take you back to the previous example when I was showing you how to find the inverse of a function using an algebraic method, you may have remembered that my first step was actually to exchange the x and the y. Now again, going back to last lesson, and that's why it's so important that we keep on reversing back to the original lesson on functions, is we talked about the x in a function referring to my input, and also we referred to as my domain, and the y referring to the range, correct? So when it comes to finding the inverse of a function using an algebraic method, the first thing that we did was we exchanged the x and the y in both the function and the original function. So by changing that, what we have achieved as well is that we have exchanged not just the variables, we have exchanged the domain and the range. Okay, so what happens with the domain and the range of the inverse function? They swap around. What was the domain of an original function is now the range of the inverse function, and vice versa. What was the range of the original function is now the domain of my inverse. So let's say, for interest's sake, I've got the function f of x equals to x squared. Okay, the inverse of that function is going to be f minus 1 of x, and you can work it out using the method that I showed you before, is equals to plus minus the square root of x. Okay, let's have a look at the domain of this function. Now remember that this is your standard quadratic function or parabola as we know it. Okay, and if you look at the domain of that function, we can say the domain of this parabola is x element of the real number. So all real numbers are part of the solution. In other words, you could substitute any value for x and get a value for y, and that's basically the definition of your domain. The range, however, and again thinking about what values am I going to get when I substitute any x value in here, I'm going to get y values, but these y values have got a specific property, and that is that these y values have to be bigger than or equal to 0. Okay, so the range in this case will be y element of the interval from 0 to infinity. Okay, or you can also say y bigger or equal than 0, and that's the range of a function. Okay, the inverse of a function, however, when you look at that and you now want to, so this will look something like this, and I'm going to show you graphically later how you find the inverse of a function. So this will be the function plus minus or root of x. Okay, the plus root of x is the positive side, the negative root of x is the negative side. However, when you look at the domain of this function now, and remember, because this is the inverse of x squared, remember what happens with the inverse function, the domain and the range swap around. So what is going to be the domain of this function now? It's going to be the range of the original function. So instead of using y, of course, because I'm talking about domain, I'm going to use x. So I'm saying the domain of this function is x element of the values from 0 to infinity, or you could also write it as x bigger than or equals to 0. And why is that? Because remember that you have a square root, so for you to get any real values out of there, the values of x have got to be 0 or bigger than 0. Okay? What values do you get from there? So that will give you positive and negative values. So I can go here and I say that the range of my function can then be written as y element of the real numbers, because whatever value of x that we substitute in here, provided that that value is a value positive or 0, will always give us a positive and a negative value. So that will give us a wide range of y values. So what do you need to know from here in essence is that the domain and the range of an inverse function are the reverse of what they were in the original function. So the domain of the original becomes the range of the inverse, and vice versa. The range of the original function becomes the domain of the inverse function. Before I move on from here, and I've just spoken about domain and range of an inverse functions, I'm going to just refer to this particular function. If you remember from last week when we did the concept of function, remember that we talked about using a straight edge to be able to determine whether the function was a graph represented a function or not. So if you use the vertical rule here, okay, the vertical line test on this function, the function f of x equals x squared is a function, right? Because remember that the ruler doesn't touch the graph more than once. However, when I go to the inverse, you will see that the inverse is not a function. Okay, and this is something very peculiar that happens to quite a few functions. Okay, sometimes your functions don't have an inverse that are functions. Okay, and that is basically given because in some cases your functions are not one-to-one functions. The only functions that you will have which have inverses that are also function are the so-called one-to-one function. Remember what we said last week about this function? We said that this quadratic function was a one or a many-to-one function. So many-to-one, which means you have two values of x for the same value of y. So that's the concept of many-to-one. Okay, now because your inverse, your domain and your range swap around, in other words your input and your output swap around, okay, if when you were looking at the original function you had a many-to-one function, okay, when you look at the inverse, now that is also going to reverse around and you're going to have a one-to-many. And remember what we said last week, one-to-many is not a function because now you have a single x for two different values of y. How can we correct this? And that's what I explained to you last week, that sometimes you have to make certain restrictions. So if instead of using this function as plus minus the square root of x, I said I want to just look at f minus 1 of x as the square root of x, in other words looking at the positive side of it, which is this one, this side of my function, that on its own is a function. Okay, so is if I only wanted to look at the f minus 1 of x equals to minus the square root of x, that on its own will also be a function. Okay, when I look at the function as a plus minus root of x as it is now, I don't have a function. So what am I trying to say here is that sometimes for you to convert a graph into a function, you have to establish what we call restrictions to the domain. So you can restrict the domain of your original function so that your inverse becomes a one-to-one and it is a function, and that is the case here. So what restrictions to the domain I could make here? that I'll make the restriction that either x is bigger or equal than 0, which only show this part of the graph. And because that part of the graph is a one-to-one function, then my whole inverse will be a function. Or you could say x less than 0, in which case you're only showing this side of the graph, and because that side of the graph is a one-to-one, it will also be a function. So the inverse will also be a function. Okay, so sometimes the whole graph of a function is the inverse of a function is not a function, but you can convert it by using restrictions to the domain. Okay, there you have it. So now we've seen functions, we've seen split functions, we've seen inverse functions. That will wrap up the concept before we introduce limit. Our next lesson we're going to be introducing limit, which is also a very important concept when it comes to both differential and integral calculus.